Welcome to Ask and Learn.
Alright, so let's solve this engineering mechanics statics problem. And this is a bar when we apply 30 Newton load on the tip of this bar, so it rotates the tip of the bar by 15 degree, right? So we'll need to find these forces also, this FA force and FB force, right? So let's apply some moments equation at point B, right? So applying the moment equation at point B, let's summation of all moments at point B is equal to 0, right? So summation of all moments at point B is equal to 0, right? And this is 30 Newton force which acts at the distance of 1 meter, right? So 30 Newton minus if A force, right? So if this acts at distance of 2 meter, right? And all these equal to 0, right? And after that the FA force is equal to 15 Newton, right? So this is FA force which is 15 Newton, right? And all we need to find the FB force also. So applying the moment equation, the equilibrium equation at point A also, right? So summation of all moments at point A is equal to 0, right? So summation of all moments at point A is equal to 0, right? And here it is 30 Newton force, so it is 30 Newton and it acts at the distance of 3 meter, right? So 3 meter and minus FB force. So this FB force is in the upward direction, so this is FB which acts at the distance of 2 meter from here, right? So all these are equal to 0, right? So after finding FB is 45 Newton here, right? So this FB reaction force is 45 Newton, right? So after that we need to find the stiffness and the stretches in each spring, right? So to find the stretch in each spring, the formula is force at A is equal to the stiffness of spring and the stretch in the spring at point A, right? And for point B or for the spring, the second spring, the force B is equal to the stiffness of spring and the stretch in the spring B, right? And these two stretches are here, right? So these are two stretches which is here, one is here and the second one is here, right? So we will need to find these stretches, which is xb here, right? And this is xa. So we have found that if A is 15 Newton, so this is 15 Newton, which is equal to the stiffness of spring and the stretch in the spring, right? So stretch in spring A. From here, XA, which is stretch of spring A, which is equal to 15 divided by the stiffness of spring, right? So 15 divided by the stiffness of spring. And for spring B, the FB force is 45 Newton. So this is 45 and the stiffness of spring, and this is the stretch in the spring B, right? So from here, the stretch in the spring B is 15, 45, sorry, 45, 45 divided by the stiffness, right? And we need to find the stiffness of the spring, the stiffness of the two springs, right? So from the geometry we need to find, from this geometry we need to find, so this is 45 divided by the stiffness, and this is 15 divided by the stiffness, right? And from this geometry we need to find this d here, right? So this d could be found by this formula. This is 15 degree, right? And this is d divided by 45 divided by k, right, which is the stiffness, and which is equal to 2 minus d, right? So this is 2 minus d. This distance is 2 minus d here, right? And 2 minus d divided by this distance, right, which is this stretch of the spring, right, which is 15 divided by k, right? And after solving, this d is equal to 1.5 meters, right? So this is 1.5 meters, right? And this angle, this 15 degree is uh, given here, right? So we need to find the stiffness of spring. So the stiffness of spring is equal to uh, the, that 15 degree angle is equal to sine 15 degree, which is equal to 45 divided by k and whole divided by d, right? And we have found that d is 1.5 meters, right? So after simplification, we have found this k here, right? So this k is equal to 116 newtons per meters, right? And this is answer to this problem.